All right, good afternoon, everybody. If you are hearing me, please confirm by saying good afternoon in the chat. We're going to get started shortly, so I just want to make sure everybody could hear and everybody could see. So I'm currently looking at the chat, and I'm also checking in who's with us today. All right, so as everyone says good afternoon, I'm just going to run through a few things before we begin. One, this class or this session is to revise each topic for the exam. And so what I want you guys to do is you're not going to be writing the entire class. There will be things I'm going to ask you to write, and then there are going to be things that you should take a screenshot of to write after so that we can maximize the class, because I don't want us wasting time just writing. I really want us to focus on understanding. I want us to also focus on identifying our weaknesses and our strengths. So as we go through each topic, I'm going to make sure I highlight the name of the topic so that you could write it down. And after we finish it, you're going to write down whether you're going to rate the topic 1 to 10. 1 being that you're totally weak in the topic area, 10 being you feel 100% confident, so that by the end of the session, you should know where you should put your energy into when it comes to revising. Okay? Because algebra is actually the most important topic because it is used in all the other topic areas. So that is why I decided to start with this one. Okay? So another thing I'm going to ask you a lot is if we good to go, not good to go. And don't be afraid to say not good to go. You don't have to send a message to the general chat. If you're not comfortable, you could send me a direct message by clicking on the blue tab in the chat and sending the message to me directly. But I think that if you have a question, if you share it with the group, it may help somebody else who may be afraid to ask the same question, okay? This is a safe space. Don't be afraid to communicate with me. Don't be afraid to share your answer when I do ask questions. That's how we learn, okay? So it's about 4:58. We're going to start shortly. So I need everybody to first head up your books. You're going to head up the topic, algebra. So like I said, there are going to be some things I'm going to ask you to write and some things you don't need to write. So this is something you have to write. So you're heading up session 1. Algebra. So I know we have different persons in the chat. This session again is meant for persons who are going to sit the exam. So these are things you should have learned, but you're probably not confident with. So for those persons who are here, just to, pick up what you can pick up, just follow along. I'm not going to teach in depth. I'm going to be reviewing. So that's just a disclaimer, because obviously there's no way I could teach the whole topic in 2 hours. So we're going to be zooming through, trying to touch on everything, just to refresh your memory and highlight again what you're strong in and what you're weak in. Okay, so now we're going to jump right into it. We're going to start off with our first topic. So this is the first topic you're going to write down: integers, which deals with positive and negative numbers. No, the reason why we're starting off with integers, for those persons who already start looking at past paper questions, you would realize every single topic deals with integers. They're never gonna ask you to just work on questions with positive values. There always will be given a question with negative numbers, so you must know your integer rules. All right, so before we get started, if you are ready, you have headed up session 1. The first topic, integers. I need you to type in the chat, ready. And once I see majority of persons respond, I'm going to begin. I hope I'm not talking too fast. I hope everybody understands. My voice is a bit hoarse, so I apologize for that. But I hope everybody's understanding me clearly. I'm super excited about going through this session with you guys. Awesome. So as everybody has continued to post, I'm just going to quickly jot down a summary of the rules you should know. So let's start off with multiplying and dividing, because that's the easiest set of rules that you should be able to remember. So multiplication and division rules. All right. So when I multiply a positive number by a positive number, the answer is always positive. We should know that a positive and a positive gives a positive. Then we have a case where if you have a positive number times a negative number, and even if we switch it, a negative times a positive is basically the same thing, right? The answer for this is always negative. And our last case is when we have a negative times a negative, our answer should always be positive. So I'm just going to recap that quickly. A positive and a positive gives a positive. A positive and a negative gives a negative. And a negative and a negative gives a positive. Another trick in maths is trying to look at a trend or a pattern that makes it easy to remember. So let's look at something. You realize when the signs are like, the answer are always positive. So when it's two positives, you get a positive. When it's two negatives, you get a positives. Everybody with me? If you're with me, say with me, with you. Confirmation, because again, these are things you must memorize for the exam. You must memorize these rules, okay? Now, when it comes to addition and subtraction, the rules are a bit different. So what we're going to do, we're going to start off with when the signs are alike. So for example, if I have -2 minus 3, this is something I want you to think about if you're ever in a situation you forget the rules. If you owe somebody $2 and you borrow $3 more, aren't you more in debt? So obviously your answer will be negative, and instead of owing them $2, how much do you owe them now? You owe them $5. So anytime, no matter if it's algebra, fractions, you use this type of thinking when you're working out integers, because these rules are very easy to forget. So everybody with me? When the signs are alike, when it comes to addition and subtraction, you add the two numbers and you put back the sign. So I'm just going to quickly ask everybody to try this one for me. -5 minus 2. Type in the chat quickly what you think the answer is. Don't be afraid to get it wrong. This is our chance to participate. Quickly put your answer in the chat. You can send it to me only. You can send it in the chat. Doesn't matter. This is why we're here. Mistakes are meant for us to learn. So I'm seeing two different answers. I'm seeing 3. I'm seeing -7. Don't forget the rule, guys. If the signs are alike, so you see this is negative, you add the two numbers. So that's 5 and 2 is 7, and you put back the sign. Okay? So if you made a mistake before, I hope that you see what it should be and why it should be that. You owe somebody $5, you borrow $2 more from them. Now you owe them $7. Okay? Let's look at when the signs are different. So when the signs are different, you have to do the opposite. So look at this. When the signs were alike, we had to add. So obviously maths is about balance. So when the signs are different, instead of adding, what do you think you need to do? You need to subtract, but it's different. To decide which sign you take, you have to look at which one is the bigger number. So for example, I have -2 plus 3. So the difference between these two numbers, 3 minus 2 is 1. Which one is the bigger number, the negative number or the positive number? The positive number, so the positive number wins. Let's try another one. -5 plus 2. If we look at the signs are different. So we know we need to subtract. 5 minus 2 is 3. Who is the bigger number? The negative or the positive? The negative. So our answer would therefore be negative. Everybody with me? So we're going to try one quickly. Negative 10 plus 2. Everybody tell me what you think the answer is. Let's go. Integers is your top priority for every single thing that you do. If it's one thing you always should be practicing, is making sure you remember all the integer rules. You remember how to add, subtract, multiply, and divide negative numbers. All right, I'm seeing some answers coming in. Very good, everybody. The signs are different, so we subtract. 10 minus 2 is 8. Which one is the bigger one? The negative or the positive? The negative is bigger, so the negative one is going to win. And so our answer is negative 8. All right. Now, sometimes you have situations where, a lot of times actually in the exam, where you have something called clashing signs. What do I mean by clashing signs? Look at this example. 2 plus negative 1. In no case should this ever happen. Somebody has to win. And so you think about the rules that you learned before. When a positive and a negative come together, what does it turn into? A negative. So this will become 2 minus 1, which is just 1. Similarly, if I had 2 minus negative 1, what do we remember about two negatives? A negative and a negative is always what? A positive. And so this would become 2 plus 1, which gives us 3. So these are the things we have to remember. Clashing signs, what happens when these two things come next to each other? What happens to these two things when it comes to next to each other? We have to make the adjustment, okay? So now that we have revised quickly our integer laws, we're now going to jump into the actual algebra topic. But just to quickly recap all of the rules, let's start with multiplication and division. Now, guys, listen, even though I didn't do division, what do you think multiply/division means? It means that the rules are the same, okay? If I divide two positive numbers, the answer is positive. If I divide a positive and a negative, or a negative and a positive, the answer will be negative. Similarly, if I divide a negative by a negative, my answer is going to be positive, okay? So don't ever feel like we didn't touch division. It's the same rules for multiplying and dividing integers. Here, when the signs are alike, what do? We add the numbers, we put back the sign. So that's how we got -7 when we subtract 2 from -5. When the signs are different, and you should know some keywords, difference mean to subtract. You subtract the two numbers and your answer will take the sign of the bigger number, okay? And we just spoke about the clashing signs. All right, everybody good to go? I need you to say good to go in the chat. Let's keep it moving. Let me know if these are things you knew already, if you kind of refresh your memory, you're feeling a little bit better about it, because as we go into the topics, we're going to go into a lot of more challenging questions with that. All right, so let's get into our first algebra topic. Addition and subtraction. So far in your books, the only thing you should have is integers. And I need you to put your rate out of 10. How you feel about integers. If you feel confident, give yourself a 10 in your books, because when you start to revise, you realize we're in February, we got some time. When you start to revise, when you go back in your checklist, you should be able to say, okay, a week in integers, I need to revise this again. Right now is about being strategic. So I know you're sharing it with me in chat, but make sure in your book, everybody should have number 1, integers, rate 1 to 10. If it says, let me put 0, because I know some people be honest with me and they tell me 0. They're not good at all in integers. Be honest. If you know it's 0, put 0 in your book. Okay? So the next one that you're going to write on your list, number 2, is addition, subtraction of algebra terms. So everybody should be writing this down now. This is our next major topic that we're going to be covering. And as you write that, we're just going to write down the rule because this is something we need to know. The rule is you could only add or subtract like terms. So as you guys write, I'm just going to quickly recap what like terms mean. When you look at an algebra term, let me give you an example. 2a, you should know that we call the a the variable, and you should know we call the 2 the coefficient. So the number in front of the variable is called the coefficient. When we are looking at like terms, our focus is the variable. It's terms that have the same variable. And if I look at 2a and 2a square, I have a general question just to see what everybody's thinking. Are these two like terms? Is 2a and 2a square like terms? Yes or no? Don't be afraid to tell me the truth. I need to see what we're working with to make sure everybody's on a good term, good place. I'm seeing no. Okay, for somebody who may not be sure, you should remember what a square means. A square means a times a. That's a double variable. Even though it has one letter, this power indicates that it's two a's being represented. So that's completely different than 1a. So these two are not like terms. So when you are trying to identify like terms, you must pay attention to the letter, aka the variable, and the power attached to that letter. Because if there's different powers, that means it is different variables. All right, so let's jump right into it. I'm just gonna do a quick recap using some examples for persons to just, big up your memory. So let's start off with the first example 1. You don't need to write any of this. Just look, make sure you understand, make sure you remember. So we have something easy, like 4a plus 3a. When I look at this, you have to think critically. Don't ever just jump into something and try to calculate. Ask yourself, does this apply to the rules? Can I add these two things? Do they have the same terms? When I have 4 A's and I have 3 A's, the answer is yes. Now, another mistake students make, look at this. Some people would write 7a squared. Why is this wrong? When you add something together, aren't you just grouping it together? You can't change the things that you're putting together. So there's no way you could jump from an A to a square by adding things together. So something that you could do to help with this is assign an object to the letter. So for example, I would say if I have 4 apples and I add 3 apples, how many apples would I have? I wouldn't turn into something else. I would end up with what? 7 apples. Everybody with me? Because again, when you're nervous, you think fast and you mix up the rules. You have to make sure you clarify these things in your mind. So let's take it up a next notch. B. If I have 3 P's plus 2 M's plus 4 P's plus 3 M's. My question to everybody, can I add anything here? Yes or no? Quickly. When you look at this expression, can I add anything here? When you look at it, you realize, okay, I have 2 different variables. I have P's and I have M's. I can add my P's together and I can add my M's together. So I need to put them, group them. I like the words. I love any feedback we're getting in the chat. I have to put the like terms together. So I must put the P's together. Anybody realizing how I circling as well? You realize when I circle the variable, I'm also circling the operation in front of it because they are attached. So when I rewrite, this would have to be 3P plus 4P. You're grouping them together. Plus 2M plus 3M. So our final answer would be 3 plus 4 is 7P. Another thing I want you to pay attention to, you realize how I'm coming down with my solution. Most people tend to go across. My suggestion, my recommendation to you, if you come down, you could see your progress easier. You could pick up on mistakes easier. Agree or disagree? So when you look at this, you could tell these two make this, and 2m plus 3m gives us 5m, which is our final answer. So we're looking at being strategic with how we express our solutions. No, let's be real. You would never get a question like this. Why would you never get a question like this? Because it has all addition. So let's look at a question that seems more realistic or on CXC level of difficulty. So let's try this one together. C, 2p plus 3m minus 5p plus 2m. Same rules, let's group them together like terms. So I have 2p and I have another p, but it's 5p. And what is in front? Subtraction. So it has to be minus 5p. So this gone, this gone. What do we have left back? The m's. So plus 3m plus 2m. Now, when you look at a question like this, you have to pick. You see, anytime you got subtraction, the first thing should come to your mind, integers. You are subtracting from a smaller number. What does that mean? Your answer must be what? Negative, right? So think about the rules. The signs are different. So I have to say 5 minus 2 is 3. And because it's p's we're dealing with, you put back the p. And would it be positive or negative? That's a question for everybody. Would it be 3p or negative 3p? I've seen some people sending the answer. Because you should remember which one is bigger. The 5 is bigger, so it'll be minus 3p. Very good. Plus 3m plus 2m, 5m. That's easy stuff, straight to the point. All right, now, keeping in mind, we're just going to do one more. We're going to keep it moving because we just want to touch on this a little bit to make sure everybody's okay with addition and subtraction. If I had 2a squared plus 3a plus 5a squared minus a. Can I do anything here? Oh, and let me add on one just to make it spicy because, you know, CXC like to make everything spicy. So let's add on a little something at the end. Can I add and subtract anything here? Second question, how many different terms do we have? Is there 2 different terms or 3 different terms or 1? That's another important question because when you get to your answer, you should know how many terms you should be looking for, right? Okay, excellent job, everybody. Very good. So let's follow the regular steps, grouping, right? So we have a squared. So that's 2a squared plus 5a squared. Then we have the a's plus 3a minus a plus 5. Everybody okay with this? So we should be good to go. Next one, if I have 2a squared and I add 5 more, how much will I have? I will have 7a squares, right? Plus, if I have 3 a's, even though there's no number in front of the a, anybody could tell me what the coefficient of a is by itself or any variable by itself? Excellent. You must know this because students always confuse this. If you have a, it means 1a. But CXC expects you to know that because when you ask for an apple, do you say, can I have 1 apple? Like you ask for an apple. It's the same concept. So if I have 3 a's and I take away 1, I would be left back with what? I would be left back with 2 of them. Can I do anything with this 5? Whenever you cannot do something with something in an equation, you put it back. You put it back. You can't just throw it away. Okay, that's another important concept. All right, how are we feeling about addition and subtraction? We good to go? So these are the basic rules. You group your like terms. You add what you can add. You subtract what you can subtract. You put back what you cannot use. Okay? All right, so let's get into now the second part, the laws of indices, okay? Now, this is where things get sticky because when students do this, they just forget everything they learned from before. So I'm asking you to stay focused and to make sure you understand the difference. Now, I want to take this opportunity to make sure you understand what this word means. The word indices is the plural word for index, which is another word for power, and another word that represents the same thing is exponent and order. You see how much words mean the same thing? So if I have a to the third power, I could say a to the third index. I could say a to the third exponent. I could say a to the third order. You know why it is important to know these words? And indices is just the plural of this one. So indices is the plural of index. I tell my students all the time, you need to know the language. You realize CXC now gives more worded problems. If you don't know the words, what you're going to do? So please make sure you remember indices, index, power, exponent, order, all means the same thing. All right, so we're going to go through these laws quickly. The first one is easy. If you multiply two variables with the same base, you should know what to do with the powers. You have to add the powers, m plus n. So quick example, p to the third power times p to the second power. Anybody could drop the answer quick while I write up the next one. What's the answer? P to the third power times p to the second power. Excellent. So you know it's going to be p3 plus 2, which is equal to p to the fifth power. You do not multiply the powers, you add the powers, okay? Then we're going to come to some examples with some coefficients. But for now, that's all you need to know. Let's look at what happens when you divide. Division is the opposite of multiplication. And I want you guys to always keep in mind, math is balance. So let's say you remember one rule and you can't remember the next rule. If you remember balance, you would know if when you multiply, you add. Obviously, when you divide, what you're going to do? Subtract, because subtraction is the opposite of, subtraction is the opposite of addition. Right? So let's do another example. P to the fifth power divided by P. Let me see if anybody could figure out this one. For those who don't remember, if I have P, P has a power and a coefficient of 1. So P by itself has a coefficient of 1 and a power of 1. So here, even though there's no power, there is a power. It's understood to be 1. So here, if we apply the rule, P5 minus 1, we get P to the 4th power. All right, how are we feeling so far? Are we good to go with the first two? Talk quick, let's go, let's go. Good to go? You're saying good to go if you're good to go. All of this is quick revision, basic stuff, basic stuff. But things that we need in order to continue, things that we're gonna need for the higher level questions. All right, so let's keep it moving. C, anything raised to the power of 0 is? Oh my God. Please keep your mics on mute, please. Thank you. One. Anything to the power of 0 is 1. No. Someone indicated that they don't understand. So is it okay if I do a quick example for persons who may not remember the laws? I want to show you guys something, right? So let's do something quick. P to the second power times P to the third power. So everybody should be watching. Even if you remember the rules, it can't hurt to understand, right? So P to the second power means what? P times P. Do we agree? Times P to the third power. What is P to the third power? How many P's is that? That's 3 P's. So that's P times P times P. When you look at this, how many p's do you have in all? How many p's are you multiplying in all? 5 of them, innit? 1, 2, 3, 4, 5. So that's how you're going to end up with p to the 5th power. But we understand that if I had p to the 20 times p to the 40, do we have any time to literally write out all them p's? No. So they came up with a shortcut. And the shortcut is you just add the powers. So that's how we end up getting 2, which is this 2, plus the 3, which is this 3, which gives us p to the 5th power. Everybody with me? Everybody see it now? Feel a little better about it? Now, when it comes to division, I hope everybody knows this because this is something you're going to need a lot. Anytime they tell you to divide something, you could do it 2 ways. So let's try this one. P to the 5th power divided by p to the 1st power. Do you know you could write it like this? P to the 5th power over p. Everybody knows that, right? That this line means division. So I could write p times p 5 times. That's 5, right? Over or divided by p. And everyone should also know when you divide it like this, you could cancel what the numerator and denominator have in common. And if you look at this, I could cancel once because there's 1 p at the bottom and there's enough p's at the top. So if I cancel this, p can go into itself once. I cancel this, p can go into itself once. You realize how many p's we have left back? How many p's we have left back, guys? In p to the 4th power, 4 of them. So if you're in a case where you doing something, you forget what to do and you got some time, you don't be afraid to do it the long way. If it makes sense to you, if you understand it, or you want to back check, that's something you could do. All right. So we on to the 3rd rule. Anything to the power of 0 is 1. So that means a to the power of 0 is 1, p to the power of 0 is 1, m to the power of 0 is 1, 2 to the power of 0 is 1, 100 to the power of 0 is 1. Please don't forget this. CXC brought a question one year and students they forgot and they missed an easy answer because they forgot that anything to the power of 0 is 1. D, if I have a raised to the power of m, and n outside, everybody should know brackets have 2 meanings. What's the 2 meanings for brackets? Brackets could either mean do it first. What's the second meanings for brackets? Or it could mean to multiply. So in this case, what do you think we have to multiply? We have to multiply what is inside the brackets by what is outside the brackets. So it means m times n. So let's do a quick example. P to the 2nd power and the 3rd power outside. Everybody, what the answer for this one is? We only got 2 more to go and we almost finished the rules so we could get into some actual questions. What is my answer? I'm watching. What is my answer? So I love when students make mistakes because it's an opportunity to learn. You see, when we spoke about rule number 1, I have a question. Is it the same thing? Look at it. It is not. Here, you're multiplying 2 different variables with 2 different powers, right? Here, we're multiplying something inside the brackets by something outside. Don't forget the rules. So it's supposed to be p 2 times 3. That's the only time you should be multiplying the powers when it comes in this form. So your answer is p to the 6th power. So those who made a mistake, I hope you understand and see it. And you're good to go. All right, next one, E. This is something that you should know because you're going to use this in matrices. You're going to use this in Vectors, no, not vectors, but matrices for sure. I think in transformations. So this is a concept that's very important, the inverse function. Anytime you have anything raised to the negative 1, it just means 1 over that thing. So what do I mean by that? How do you know when to do it first or multiply? That's an excellent question. Okay, so let's look at these two examples. 2 plus 3 raised to the power of 2. Here, what do you think the brackets mean, everybody? Do it first or multiply? What do you think? And this is a question for everybody. It's a serious question. What does this mean? The brackets here mean do it first or multiply. If you look at this, is there anything to multiply outside by anything inside? All we have is a square. But if you look inside, there's something that you could do inside. So that tells you to do that thing first. So this would also mean 2 plus 3 is 5, and 5 to the second power. And you should know anything to the power of 2 is multiplied by itself twice. That's 25. Now, look at this one. 3 to the second, open brackets, second power. Not the second power, sorry. 2. What do you think this brackets mean here? Does this bracket means do it first or to multiply? Because if you look at it, you can't do nothing inside the brackets. So the only thing left to do is to multiply what is outside by what is inside. And so this actually means 2 times 3, which is 6. So you see, I love when people ask these questions so we can get clarity. Another perfect example would be something like this. X plus 2, and you put a 3 outside. Here, no, let me ask this one. Which one does this mean? Do it first or multiply? So you see, we have half. We got some people saying do it first. Then we got some people saying multiply. If you look at the rules, right? At this moment, there's no value for X. X has no number. It's just a variable, which means we cannot add X to 2. So there's nothing to do inside the brackets, if you see what I'm saying. So this means you have to multiply everything inside the brackets by everything outside the brackets. Everybody see what I mean? For those who thought so? Nope, because nobody gave you a value for X. This is just an expression. If I had told you X had a number or any value, then that's different. We're going to come to expanding brackets shortly, so I just wanted to get to that point. So let's get back to the point we were making about the brackets. This is just clarity, because this is important for us to clarify now. So thank you guys for your questions. So let's look here again. If I had 3 inverse, because that's what this means. Anytime you see the power to -1, this means inverse. And if you don't know what inverse means the opposite. Okay, opposite, multiplication opposite. So what does this mean? This means 1 over 3, which actually means 1 divided by 3. Everybody following? If I had X to the -1, what is this the same thing as? 1 over X. Everybody okay with that? So these are the rules. There's one more, but for now, we're going to stick with the first 5. So that's it for the laws of indices for now. If everybody feel good to go, say good to go. And you're going to do your rate for this one. What is your rate for the laws of indices in your book so that you can know how strong or weak you are? We're going to do a few questions and then we're moving on. Now, for the purpose of covering as much as we can, we're going to maybe go a little later than 7 for those who can stay and continue, because I really want to get to the past paper questions. So I'm going to give you one major question, guys, and I want to see if you could handle it. All you got to do is tell me if you can answer it or not. And then and then we're gonna move on. So let's do some quick practice questions using the laws of indices. So let's try this one. 2m squared p to the 5th power times 3m to the 3rd power p to the 2nd power. All right. So my only question to you is, do you think you can answer this question? I'm looking at the chat right now, so I'm expecting to see yeses or nos coming through. And be honest, be honest, be honest. So I'm gonna do it. I'm gonna do it. I'm gonna do it. And then I want you to look at it, get your own answer. And then we see if you are on the right track or not. No, here we see we have variables and you have to look at both sides, right? I have m's on both sides, so that means I could apply the first law by adding the powers for the m's, right? 2 and 3. But before that, I have to pay attention to what? Because that what students do. Students just jump right into the powers. No, what comes first in both terms? The coefficient. So my question to you, what is the coefficient answer? Is it 5 or is it 6? Which one is it? Is it 5 or is it 6? Excellent job, everybody. It's a 6 because you have to say 2 times 3 is 6. The regular rules apply to the numbers. The only thing you're adding is the powers of your variables. So let's look at our m's. We essentially adding all the m's together. So that would be 2 plus 3, 2 plus 3. Then we have to add the p's. What's the p's looking like? 5 and 2. 5 plus 2. So our answer is 6m to the 5th power, p to the 7th power. All right, obviously that's too easy. So I'm going to take it up a next notch. Negative 5k x to the 3rd power, close bracket 2. Now, this is a question I have to ask everybody. Can you answer this? Yes or no? Honesty. Let's go. If you're not sure is the answer. No is the answer. I love the honesty. That's why we're here. We're not here to just focus on easy questions. We got to look at the questions that we know we're going to struggle with. So that's the next level we reach now. We're going to answer questions that students generally struggle with. All right. So let's take a look at it. How many different terms, how many different elements? Canava, I see you writing up my board. Stop. Thank you. All right. So question, how many different elements is in this term? How many different parts then? When you look at negative 5k x squared, how many different parts are in there? Are there 2 different parts, 3, 1, 4? How many do you see? That's important for you to answer. Take a try. Excellent job, everybody, because that's the first thing you need to know. You have your coefficient, which is the negative 5, right? You have the k, and then you have the x to the 3rd power. So everybody get that. Now, which law this gonna deal with? Anybody remember which law this speaks about? Which law talks about brackets and a power outside? Law number 4, right? And what does it tell us to do? We got to multiply the powers outside by the powers inside. So let's check this out. Does k have a power? Yes, k has a power of 1. Do we agree? Yes, we do. Does negative 5 has a power? Yes, it does. It has a power of 1. So what we need to do is multiply all the powers inside by all the powers outside. So let's take a look and let's do it slowly. So let's start with negative 5. Negative 5, it has a power of 1. What are we multiplying it by? 2. Everybody following that first part? Then we have k. K has a power of 1. What are we multiplying it by? 2. Then we have x to the third power. What are we multiplying by? 2. Now, why are we multiplying everyone by 2? Because this square is applicable to everybody. You have to apply it to everybody in the brackets, right or wrong? So before I continue, let me know if you understand how I got this first step before I even move any further. If you got it, say got it. If you don't got it, say don't got it. Let's go quickly. Okay, seems like majority persons have it. Persons who don't, if you know you're new and you never did this before, you know, it's okay. Just give yourself patience. We're going to go through it. All right, let me break down an easier one. Of course, that's why we're here. So I'm going to use an easier example to apply this harder example. So let's try something like this. Let's try something with no coefficient. P to the second power, Q to the third power, and 5 outside. So everybody, let's take a pause for this one and do this one first to make sure you understand the why before we get the harder one done, okay? So there we go. How many terms inside this bracket here? 1, 2, 3. Everybody agree? 2, right? Which law are we using? The law that tells us whenever you have a power outside and the brackets mean to do what? In this case, the bracket tells us to do what? Multiply, right? So we need to multiply what? 5 by the 2 different things. So what are the 2 different things that we have? We have P to the second power and we have Q to the third power. And so what are we multiplying by? In the 5 outside. Let's go back to the law. Always go back to the law. Then what the law tell us must do? If we got a power inside and a power outside, what is the rule? To multiply them together, right? So here, all I did for now was put back the P square and the Q cube. So I am going to multiply by what number? 5. And you realize why we had to separate them, because they're 2 different variables in one. So what would be my final answer? P to the 10th power, because 2 times 5 is 10, and Q to the 15th power, because 3 times 5 is 15. Everybody understand this one a little bit better? So all we did for the first one up here is include an example with a coefficient, which is -5. Don't let the -5 punk you. I just tell my students all the time, you have to be a little gangster and not afraid to try. Don't let it intimidate you. So all I did, you see, look at how we broke it down. So we have the -5 power 1, the k power 1, and the x to the third power. I didn't make that up. We know anything by itself has a power of 1. Agree or disagree? And you also know whatever outside, you gotta multiply by what inside. So that's all we did, step by step. So let's go. That means, what's the answer here? -5 to the second power. Do we agree? K to the second power and x to the 6th power. Everybody with me? Talk to me, talk to me. Are you with me now? No. What is the only thing that I should change? What is the only thing that could change? Don't we know how to find the answer for this? Doesn't this has a value? What does -5 square mean? Doesn't that mean -5 times -5? And you put back everything else because it don't change. And we know a negative and a negative is a positive. We can't forget the rules. So 5 times 5, -5 times -5 is +25. So this is our final answer. So this was our first look at a CXC level question. We're going to look at another one because at the end of the day, confidence is key, right? So let's go. Another one I want to try with everybody. Let's try this one. So take a look at it. It's going to be positive this time. d to the 5th power, m to the 4th power, 3. Now, do you think you could answer this one? So let me go through. Let's go through. I know 2 has a power of 1. D has a power of 5. M has a power of 4. And what are we multiplying to all of them? We're multiplying by 3. So we're going to end up with 2, 1 times 3. D, 5 times 3. M, 4 times 3. So there we go. Answer would be what? 2 to the 3rd power. D to the 15th power. M to the 12th power. Is this my final answer, peoples? Let me see who paying attention. Is this my final answer? Do I stop here? Because that's a question you have to ask. Every time you do something, watch what you do and say, okay, can I do anything else or this is it? You have to do that. Practice doing that. If you look at this, you should know that I could break down 2 to the 3rd power. Very good. 2 to the 3rd power means what? 2 times 2 times 2. D, 15, M, 12. Let me see something here. Is the answer 6, D, 15, M, 12? Eye emoji. Is it 6? Is it 8? You know, I like to make mistakes students make all the time. Because somebody gonna say 2, 4, 6. Whenever you multiply, you have to say 2 times 2 is 4. 4 times 2 is 8. So it's not 6, but 8, okay? All right, excellent. How are we feeling about this now? Do we feel a little better? Are we feeling a little better here? All right, so one more difficult question with division, because obviously we cannot continue without a division question, because that's the whole point, division and the harder questions. So let's try a hard one, right? This is the bonus challenge question for everybody. I want you to write this question down and try it in your books. Do not panic. Do not panic. Everybody copy that down. Try it for me. Now, I'm going to time you guys because, you know, CXC don't give you 2,400 years to do things. And in an exam, you should be able to do this in a minute and a half. Now, I know we're not in an exam, so if you don't finish, that's okay. But you have a minute to get this done. You need to start practicing writing fast, working things out fast, because it's a timed exam. So there we go. I see one person drop the answer. Thank you very much for sharing your answer. I don't care if you have it right or wrong. I need to see what answer you guys get. So share your answer, do it, share your answer. Put your backs into it. I just want to take this opportunity to say, for persons who know you write slow, you have enough time to train yourself to answer questions faster, to write faster, to work faster, okay? Because you could know all the answers, but if you write slow and you don't finish, that could still make you fail. So I see 4 persons, 5. Don't forget, if you're not confident to send it in the general chat, you can send it to me directly. All right, time is up. Anybody else want to share their answer before we get into it? All right, so my question to you is, how many operations is there here? How many operations we have here in this question? 1, 2, 3. If you're still working, I need you to stop where you reach and to focus on the screen. Okay, so it's one person said 3. Anybody else? How many operations we have here? Because that tells you what to do first, what to do second, what to expect, what not to expect. Okay, there are 3 terms, but there are only 2 operations. And for those who don't know, I'm not sure what operations mean. Operation is either addition, subtraction, multiplication, division, square, square root. Okay, those are the things that you could do in math. That's what we call the operations. So in this expression, there are 2. So thank you everybody for sharing. And I'm just going to clarify why it's 2. Obviously, multiplication is 1. And I don't know if anybody realized that this line is the second one. And this line means what? To divide. Right? Those are the 2 operations. So the first thing you have to do is look at what you have at the top. What do you have at the top? Something times something. So anytime you get anything that looks like this, you have to deal with the thing at the top first. Then divide by the bottom. Everybody with me? Because if you don't understand what this is, we're not going to be able to answer it. So let's take a look now. Let's answer the top first. Okay, let's look at the top first. Don't forget, I see some of us made the same small mistake from before, but that's okay. That's why we're here. What do you do with the coefficients or the numbers in front? Remember, because you're multiplying, the rules of multiplication applies. So it's going to be 4 times 3, which is 12, right? Then for the variables, you apply the laws. So the laws would be what? To add the powers of the letters. So what letters do we have? We have M. So let me add the powers of the M's. What is the powers of the M? 2 and 3. So that would be 2 plus 5, sorry. Then let's look at the other variable, which is P's. And we have to add those, which would be what? 3. And what is the power on this P here? The power on that P would be 1. So it would be 3 plus 1. Everything you don't use, you put it back. We did not use the bottom. You put it back. So that's already 1 mark you get here. Everybody with me so far? So the answer for the top is 12m to the 7th power, p to the 4th power. If you made a mistake, I hope you see where the mistake is. So this is what you should have now. No, I'm going to work this out 2 ways. I'm going to work it out this way, and I'm going to rewrite it to make it easier by using the linear way. Instead of having something over something or something divided by something in this way, I'm just going to rewrite it as 12m to the 7th power, p to the 4th power, divided by what's at the bottom, which is 2m to the 3rd power, p to the 2nd power. Now listen to me. CXC gives you freedom to work your answer how you feel most comfortable. If you are comfortable with doing it this way, you do it this way. If you know it's easier for you to do it this way, rewrite it so you could do it to get the most marks that you can. But everybody understand that these 2 things are the same, right? Remember we spoke about that something divided by something is just a different way of writing division. So let's work this one out. 12 divided by 2 is 6. And because we're dividing, what do you do with the powers? You subtract the powers. So M7 minus 3, P4 minus 2. So our answer is 6m to the 4th power, p to the 2nd power. Do you see it now? If you didn't get it right before, do you see it now? So that's our practicing of the laws of indices. So everybody out of 10, drop your rate so that you know if you need more practice. You're 5, you're 10, you're 1, you're 0, you're 4, a 3. Okay. So please note, if you know you're not strong here in the session, I'm going to send y'all a textbook that you could use to get more questions and to practice, but you have to pay attention to the things you're strong and weak in. All right, so we're done with that for now. Please note, this class, I can't teach everything in depth. All I'm trying to do is to revise so that you could remember certain things and you could look at what you're strong in, what you're weak in, so you could go and put in the extra practice, okay? Because remember the laws of indices, when you're dividing, look law number 2. And something I want to tell y'all now, you see these formulas here, they don't come on the exam. You have to memorize these laws. This is the backbone of your understanding of these questions. So I like these questions, please. Everybody understand what I'm trying to say? If you don't know these, you're going to struggle. So your top priority is to memorize these laws here because they are the ones that tell you what to do, when to do it, and how to do it. Everybody see what I'm saying? So if you know that this is a part that you're not so confident in or strong in, make sure you take note of it. And what I could do coming closer to the exam is recap it. But I won't be able to like go over it, like, you know what I mean? Because we try to cover as much as we can. So don't be discouraged. If you know, you realize this is your weak point, all of us gonna reach a weak point at some point in time. You just gotta work on it from now because we have enough time to do so. All right, we're gonna do something. The third thing is 3 expanding brackets. We gotta do this quickly. It's pretty easy because I'm gonna show you an easy way to get it done. I know some people is do the foil method. I do not because students usually get confused and make mistakes. So I just kind of break it down in an easier way. So but you use what works best for you, okay? If that process is what you understand and mastered, you stick to what you know. There's a million ways to do the same thing once you use logic and you express it the right way. What do I mean by expanding brackets? So this is what we call the distributive law. This is where the brackets have a meaning of multiplying. And so I'm going to simply just start off with single brackets. But before we get going, I just want to check in with everybody. You guys ready for the next topic? If you're ready, say ready. I know we're doing a lot. It could be overwhelming, but we channeling our thug energy. You know what I'm saying? The thug energy is extremely necessary. So you can't be, you know, letting it overwhelm you. Just stay focused and take in what you can, understand what you can. I'm watching the chat. I want to make sure everybody's okay. All right. So we're going to do this next topic here and substitution. And then I'm going to ask another question. All righty then, let's get it. So whenever you have something outside the bracket, so we're going to start off with easy things, obviously. We have 3 outside and we have A plus B inside. So when we want to distribute or expand, you always look at what you have outside and what you have inside. Now, what we have outside is a positive 3. So we are multiplying by positive 3. And what is inside? A and B. And what is in between them? A plus. So let's go. So what you're going to say is 3 times A. Right? 3 times A. What is in the middle of them? Plus. And then you're going to say 3 times the second thing, which is B. 3 times B. And for those who don't know, 3 times A is simply 3A plus 3 times B is just simply 3B. Can I add these 2 things? Is this my answer? We should know that this is my answer because why? I cannot add A's to B's. So this is your answer. That's it. Pretty straightforward. Now, some students would have the 3A, 3B, but forget the plus sign. You have to keep in mind that you have to express the plus sign. Now, let's get into the dark side, negatives. Take a deep breath, don't panic. So let's start off with something easy. 2 open brackets, A minus B. Same concept, right? We multiply by 2. So it's going to be 2 times A minus 2 times B. Simple. 2A minus 2B. All right, we're taking it up a next notch. Let's look at if we had a negative number outside. So we're going to leave this. We're going to use the same numbers, but instead of positive 3, we're going to use negative 3. So negative 3, A plus B. So in this case, what am I multiplying by? Negative 3 times A. No problem. I just got a little excited, you know, so yeah, I could easily slow down. So let's go again. Here, if you look at these two, A and C, is the same question. What is the only difference? Instead of positive 3, we're multiplying by negative 3. Everybody see now? So it's going to be negative 3 times A. So let's write that. Negative 3 times A. You put back the plus, and then it's going to be what? Negative 3 times B. Let's write that. Negative 3 times B. Now, when students get here, they just make a mistake. Their mistake is they deal with this clashing signs first. No. Anybody remember what BODMAS mean? Can you guys hear me? Hello? Okay. I'm not sure how come some person's not hearing. Okay. So as I was saying, BODMAS tells us to multiply, right, before we add or subtract. So what you need to do first is multiply these two first, and then proceed. Right? So negative 3 times A, which is negative times a positive, will give us a negative 3A plus, if you can't, somebody type in the chat, because since the person can't hear me, they need to check their speaker or their audio. Because if everybody else can hear me, it's just something with their stuff. Somebody just type that for the person for me that checked the audio. To Janaya? Yeah, because she's saying she can't hear. All right, so let's go. Negative 3 times A is negative 3A plus, you put back the plus, negative 3 times B is negative 3B. Right? Now, because here you don't multiply, this is when you deal with your clashing signs. And we know a positive and a negative comes together, going to turn into what? It's going to become minus 3A minus 3B. No problem, no problem. Everybody see how we deal with the clashing signs? Because I'm going to be honest with you. You see, this is where students just lose a lot of marks when it comes to simplifying. Whenever it comes to the negative signs, they make a lot of mistakes here. And so this is something I want you to pay attention to. So the last example we're going to look at with single brackets is when you have a double negative. So let's look at negative 2A minus B. All right, so let's go, guys. Here, we are multiplying by the negative 2 again. And look at what is inside the brackets, a minus. So what are we going to end up with? We're going to say negative 2 times A. So let's write that. Negative 2 times A minus, this is the minus we're bringing down, minus, and then we're going to go negative 2 times B. Negative 2 times B. So let's break it down step by step. Same thing like we did before. You multiply first. Focus on the multiplication aspect first. -2 times A is -2A. You put back the subtraction. -2 times B is -2B. Now that we're done with that, what we see is we have another set of clashing signs, but they're negatives. And we should remember a negative and a negative is what is a negative and a negative? Positive, thank you. So it's going to change into a plus 2B. This concept is the difference between a fail and a pass and a 2 and a 1. You have to decide what type of grade you want to get, and you have to pay attention to these things. So this was the single brackets. Everybody okay with the single brackets? So this is the first thing that we looked at, single brackets. Make your score. If you feel good with the single brackets, your rate. If you feel confident with single brackets, whether positive or negative, make sure you take note of that in your book. We're going to do now double brackets. Sorry, I'm really bad at spelling, okay, guys? Don't judge me. You know, if y'all see some words that look a bit suspicious, just, squint your eyes a little bit. All right, so let's get into the double brackets. Let's get into the double brackets. So let's look at A plus B, X plus Y. All right, so quick question. How many people rate yourself right now with how you feel about expanding double brackets? Out of 10, so I could see where y'all at. How do you feel about expanding brackets? Out of 10, you don't master it, you're not so confident. I'm looking at the numbers, so I could see how much people like not okay. Okay. I'm watching. Okay. Thank you for your honesty. Okay. All right. So obviously you would have learned it one way already. So I'm just going to teach you a error-proof way of doing it. Okay. So for those who are already sure, no problem. Yeah, you could go ahead, no problem. So for those persons who feel confident with how they do it, continue to do it your way. Once you know, you don't make mistakes and you're good to go. For those persons who are not as confident, look at this way of doing it, which helps you avoid making mistakes, okay? So what I usually do is I split up the first bracket. And what is inside the first bracket? We have a A and we have a plus B. So you see how usually, if we go back up here, you realize how we just usually just take one thing and multiply it by the individual thing inside the brackets. It's almost the same thing. But what you're going to do is you're going to say A times the whole bracket. So what do I mean by that? You're going to say A times X plus Y. Then you're going to say plus B times X times Y. Plus B times X plus Y. Anybody realize what I did here? All I did was break it up so that way you could easily multiply it using single brackets. So let's go again. All I did was take the first number, which is the A, and I multiply it by the entire brackets, X plus Y. Then I took the second number, and you realize I put plus B. I took the whole plus B, and I multiplied by the entire bracket. Everybody see that? And from here, we should be able to multiply this out easily because look at that. A times X plus A times Y. We could do that easy. A times X plus A times Y. Same thing over here. B times X. So you put the plus B times X plus B times Y. So we could easily get the answer for this because A times X is what? AX. Plus A times Y is what? AY. Plus B times X is BX. plus b times y is by. Everybody see, it's a little longer, but let's be real. If it's easier, it makes more sense to try this method. Okay, I'm going to do another one. So you could see, let's use some numbers and let's use x values. So let's try this. X plus 2, x plus 3. So which one is the brackets I'm breaking up first? I'm breaking up the first bracket into what? X and plus 2. So I'm going to say x times the whole bracket, then plus 2 times the whole bracket. So let's try it out. X times the whole bracket, x plus 3, plus 2 times the whole bracket, which is x plus 3. And so we're going to end up with x times x. Follow, and please, you know what the examiners look for? The examiners care more about the working than your answer. So you see, please don't be afraid. If you need to use arrows, use your arrows, because you're showing the examiner that you understand how to multiply. Even if you make a small mistake, they would be more lenient in giving you some marks than if you put nothing at all. Everybody understand me? Y'all not hearing me? Some person saying they can't hear. If you can't hear, you have to probably go out and come back in. Okay, all right, so there we go. X times X is, you write that, X times X. I hope y'all realize the difference between my X and my times, plus X times 3. Let's go over here now, plus 2 times X, plus 2 times 3. Just a heads up, I'm gonna be sending you guys an assignment, a revision assignment, just to see where y'all are. Don't panic. It's a Google form multiple choice question quiz. And it's also for me to just see when we do another revision, what parts to focus on. So I will send that link at the end of the class. So let's go. X times X, we should know x squared plus x times 3 is 3x and not x3. Plus 2 times x, 2x, plus 2 times 3, 6. Is this the answer? I could go one more. Can I go more? But that's it. If you look at it, you could add something here. What can I add? I could add the 3x and the 2x. So we could go one more. So it's x squared plus 3x plus 2x. Think about it, you add in. So if you got 3 of something plus 2 of something, you have 5 of x's plus 6. All right, so this is just the double brackets breakdown for those who don't know. Also, I'm going to send you guys the YouTube link for this class. If you want to go back into a specific area and rewatch it, you are free to do so. So that's it. That's where we're going to stop with the double bracket expansion. So out of 10, how much you feel about expanding the brackets now? If it still feels weak, you know you need to practice, 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 practice. And we're going to quickly go into we're going to come back to this because of the time. We halfway there. So I can always come back to it in the end if you don't mind. So you could just remind me and I'll go back over it with you for a little bit. Okay, so anybody who want me to go back over that part or anything else, just let me know and I will spend an extra like maybe 10 minutes with you and go over it one-on-one or in a smaller group. So just put a pin there, okay? Yes, I got you. No problems. I got you. I got you. All right. So the next thing we're going to touch on is substitution. I really wanted to get to factorization, you know, and binary. So let's make a decision. We could do 2 examples of substitution in binary. As I really want us to focus on what students struggle the most on is factorization. So what y'all think? Should we do factorization first? Since substitution is pretty straightforward. Let's take a vote. What y'all think? Because to be honest, factorization comes every single year. There's no year the factorization do not come. Substitution don't always come. Binary don't always come. Factorization always comes. So we're going to leave the substitution for now and the binary for now. We're going to put a pin there, but I would like you to take note of this and just put a star by it because we didn't do it. And we're going to jump into factorization. For those who don't know, these are the other topics that we have to do. Solving, which is also something that comes every year. And that's linear equations. And also simultaneous equations. Also, I'm just doing a quick recap because I hope y'all know these topics, right? Inequalities. Just giving you guys an idea of what you should know. And then after solving is changing the subject of a formula. But if you could solve, you should be able to change the subject of a formula. If you don't know what I am talking about, don't panic. If you're like, what should they talking about? If you're in another farm, in a lower farm, you don't know it, you haven't learned, and you're just here to just learn as much as you can, don't panic. This is also, remember, we're just focusing on the exam students. So you're just gonna pick up what you can and just follow along, okay? And the last question topic that has come on the algebra is direct variation. And indirect variation. This does come, I realized recently, this has been coming a lot. So this is something I want to touch on before I leave tonight. Okay. So these are the priorities. Next week is algebra part 2. So whatever we don't cover here, we cover then. So we're going to now get into factorization. And I see us ending there. So let's get on to a new page. Everybody head of factorization. And what I'm going to do, I need y'all to write out this because I'm going to write the list of factorizations you should know. Okay. Again, for those persons not writing the exam and just watching, just pick up what you could pick up. The first type of factorization is the distribution. The distribution law. And I'm going to explain each. All right. So pause for cause, and I need everybody to follow me because all I'm going to do is explain the differences between them, which you should know. Okay, even if you forgot, you should know. Whenever you use a distributive law, you use it for terms that have something in common. So terms that have something in common. What do I mean? When you look at, for example, look at this. PA, let me use green so you could tell it's just an example, right? So everybody should be looking. PA, let me use yellow. PA plus AM plus BA. When you look at these three terms, do they have something in common? Look at it. Look at all three. Keeping in mind, what does PA mean? PA means P times A, AM means A times M, B means B times A. So when you look at all of them having what? All of them having an A. So I could factorize out the A. Keeping in mind that when I say factor out, the operation that we use is division. So if I divide out A from all of them, we put what is left back in the brackets. So let's look at that. When I divide out A from PA, what is left back? P. Everybody see that? Plus, when I divide out A from AM, what is left back? M. Plus, when I divide out A from BA, what is left back? B. This is how you factorize using the distributive law. Everybody see that? You look for the one thing. You could only use it if everybody that there have something in common, that thing that you could pull out. That's what you call factorizing using the distributive law. Everybody see that? If you got it, say got it. So that's the first factorization you must memorize. And this is the first one you should ask yourself. Anytime you see the word factorize, you ask yourself first, is this distribution? If it's not distribution, then you move on to the second one I'm going to show you, which is what we call grouping. So factorizing by grouping. Now, the first thing you look for when you're using grouping, it must have 4 terms. So anytime you see 4 terms, first thing should come to your mind is grouping. And something is special about the 4 terms. You have the first 2 are 2 pairs that share something equal. 2 pairs, and when I say pairs, I mean pairs of terms that have something in common. Doesn't that sound similar to the distributive law? And watch what's gonna happen. Something in common. So let's look at example. Give me 1 minute. Let's look at an easy example. I'm just gonna make up something on the spot and then we're gonna do an actual example. So let's look at this. AM plus AP plus let's say BP. No, let me use a different letter for now. Let's say BN plus BC. First thing first, can I use distributive here? Look at it. Can I use distributive for this one? When you look at that, you should know I cannot, because what is the rule for distribution? Everybody must have something in common. And when you look at this, everybody don't have something in common. So we can't use distribution. So you move on to the second one. The second one is grouping. And then the second thing you look for, does the first 2 got something in common? Does the first 2 have something in common? Does the second 2 have something in common? So that is why they call it grouping, because you're gonna have to group these 2 together and you're gonna have to group these 2 together and you factorize accordingly. So let's factorize the first 2. Both of them have A in common, right? So you pull out A, so what's left back? M plus P. Everybody see that? What does second 2 have in common? Positive B. So you're gonna say plus B, open bracket, what left back? N plus C. N plus C. Everybody see that? And if you look at it, they have nothing else in common. So this is where we stop. But there are examples where you could factorize further. And I want to show you guys that now. I need y'all to take a picture of this screen because this is something I think you need to write out, especially when it comes to the factorization laws. That's something for sure you're definitely gonna need. So just quickly take a picture of this, and this is something you would write out after class. So before I move on, so giving you 5 more seconds to do that. This is summary notes. Remember, you should have done this before. So this is just us, explaining and making sure you understand a little better. Okay. All right. So we're moving on to 3. But before we do 3, I want to do another example of grouping, an actual example. So check this one out, everybody. Let's see if we could do this one together. Look at the question. So if you look at a question like this, first thing you should think, 4 terms, ma'am, is definitely not distributive because all of them don't have something in common. So the next thing you should think about is grouping. You see 4 terms, it fit the look, but now you have to make sure, you can't just assume it. You have to make sure that you could get 2 pairs where you could group them. Can I group the first 2? Let me see if you are looking and seeing what you need to see. Can I group the first 2? What do they have in common? Yes, they have P's in common, right? Excellent. Can I group the second 2? Yes, because they have Q's in common. So let's break it down because we know to easily factorize these things out using the distributive law. So P, they have P in common. So when I pull out the P, I'm going to end up with X plus Y. Everybody agree? The second one, what do they have in common? Q. Well, what type of Q? Positive Q. So plus Q. Open bracket, what's left back? X plus Y. Anybody realizing something here? Let me zoom in a little bit. Anybody realizing something here? Something should tell you that this is not the end. When you look at this question, right? Do you realize they have matching brackets? Do you realize this bracket here is the same thing as this bracket here? That is a signal that you're doing the right thing. Because honestly, not all the time, please know, not all the time, but most times when you're factorizing using grouping, you would get something that look just like this, that this brackets match this bracket. And I want to take this opportunity to tell you, whenever you're dealing with the negative signs, if ever you realize you have different signs, it means that you made a mistake somewhere to back check it. Everybody with me? So let's get back here. So because we have matching brackets, we're going to pull out the matching brackets. So let's pull out the matching brackets, X plus Y. When I pull out, what do I mean by that? I divide out, so I cancel out the matching brackets by division. What is left back, guys? P plus Q. So that is going to go in its own bracket, P plus Q. Everybody see that? That's how you do factorization through grouping. That's it. That's a perfect example. Now, something I want y'all to know, let's say you have some time because you move fast enough and you want to back check it. If you multiply out everything, you should get back the answer you had at the beginning. That's how you could check, because factorization is the opposite of expanding. It's like you're going back and forth. And I just want to show you what I mean by that. So let's look at this. Let's take this, 3x plus y. What does 3x plus y mean? To multiply, right? 3x plus 3y. So that's going to give me 3x plus 3y. Let's factorize now. Factorizing means pulling out what they have in common. What do they have in common? 3. So if you divide by 3, put the 3 outside, what's left back? X plus y. That ain't the same thing we started off with. So that's something. Remember, we spoke about that in the beginning. Maths is about balance. Everything is balance. You could always backtrack. You could always check your answer. All right. So that's what we call grouping. Should I do one more, or everybody okay? Should I do one more grouping? With negative signs, with a negative sign? All right. So let's try an example with a negative sign, just so that you can see. 3 AM. And this is a hard one. This is a CXC one. Well, not hard, but a little bit more challenging. 6AY plus BM minus 2BY. All right, let's do this one together. Is this distributive? No, because all of them don't have anything in common. Is this grouping? How many terms we have? 1, 2, 3, 4. Can I group the first two? Yes, because they both have A's in common, so we group them. Can I group the second two? Yes, because they have B's in common. So now let's break down the first bracket. So because A is common in the first bracket, we pull out A. When we pull out A, remember we mean dividing out by A on both sides. What's going to be left back? Sorry, I did my brackets wrong here. The bracket should be the other way. So we took out the A, so that's why the A is outside. What's left back on this side here? 3M minus, we took out the A, so what's left back? 6Y. Nobody realize something? I intentionally did this, but I want to see if anybody could see anything else. Yes, that's it. You could take out the 3, right or wrong, because both of them don't have 3 in common. 3 is a factor of 3, and 3 is a factor of 6. Everybody see what I'm saying? Because students do this all the time as well. I like to make these mistakes to see if anybody realize, because you have to know and be careful about things like this. So A is not the common factor, because I could pull out 3 from here and I could pull out 3 from here. So let's go back. Instead of pulling out 3 only, I could pull out 3A. So since I pull out the 3, I divide them by the 3, this going to cancel. So what's going to left back? Only the M. Minus, when you divide 6 by 3, what do you get? 3 into itself goes once, 3 into 6 goes 2 times. So you put the 2 here, and what else is left back? The Y. Everybody see that? Let's do the second bracket. What is in common over on this side? This one is the simple one, only B, but it's a positive B or a negative B? A positive B. So plus B, what's left back? If we divide by B on both sides, cancel out, M minus 2Y. How do you know you're going right? Are we going right? How do we know we're going right? Because our brackets do what? Match. The brackets are matching. So that's a clear indication we're on the right track. So what do we do next? We pull out our common bracket, and our common bracket is M minus 2Y. And since we pulled out the common brackets, what is left back? 3A plus B, and we put that in its own bracket, 3A plus B. Everybody see that? Even though it's with a negative sign? Good to go? Remember, we can't go through every single thing a million times. It's for you to look at what you're strong in and what you're not strong in. So please take note. If factorizing by grouping is something you got to work on, write it in your book. Practice factorization by grouping. How many time we have left? We got half an hour. All right, we're on the right track. All right, so that's 2. Let's move on to the third factorization, which is the difference of 2 squares. Difference of 2 squares. Before we get into that, I want to do a quick activity to see if y'all could identify the square numbers. So all I need you to say is yes or no. That's all I need you to say. If it's a square number, say yes. If it's not, say no. Let's start off easy. Is this a square number? Yes or no? And I need everybody to answer, even if you're not sure. Yes or no? Let's go. Is 1 a square number? I'm watching the chat. I'm watching the chat. I'm watching the chat. And please note, you see square numbers. You need to know all your square numbers from 1 to 15. You need to know your square number, especially for paper 1. You need to know it out your head. You do not have a calculator, so you need to know it. All right, let's see if it is. Who is that? Seferina, stop marking up my board, girl. What you doing, girl? So let's see if it's true. 1 to the second power means what? 1 times 1. And what is 1 times 1? 1. So 1 is a square number. Everybody see that? It is very important to note that 1 is a square number because 1 times 1 is 1. Is 4 a square number? You should know all your square numbers, by the way. Eh? So let me write them out. 1, 4. 4 is a square number. Why? Because 2 times 2 is 4. So it's supposed to be 1, 4, 9. You should know at least till 100, at least till 12. 1, 4, 9. Let's go. 16. What after 16? If you don't know what I'm saying, you're looking at your square numbers. So this is 2 square. This is 3 square. 4 square. 5 square is 25. Next one, 36. After 36 is what? 49, because 7 times 7 is 49. What's the next square number? 8 square. 64. You need to know these numbers out your head. If you don't know them now, please put some time in learning them. What's the next one? 81. Very good. Next one. 100, which is 10 square. Next one is 121. And the last one is 144. Like I said, you really should be able to go up until 15. So please get on top of that, okay? No, that's the numbers, but let's continue with the terms. So 1, it is. What about this one? A square. Is this a square term? Yes or no? Yes, because the base number is A. And you know what I mean by the base number, right? Because A times A is A square. Excellent. What about this one? 2A square. Is this a square number? It is not. You know why it is not? Is the coefficient squared? No, it's not. You can't square root 2 and get a whole number. But what about this one? 4A square. Is this a square number? That is a square number because 4 and the variable is square. So that's a square number. Let's try one more. 100p. Is that a square number? Waiting for everybody. Is this a square number? No, it is not. Remember what I said, both entities must be square. The coefficient must be square and the variable must be square. Y'all see what I'm saying? Is the p square? So everybody see why it is not? Even though the coefficient is 100 and that is a square number, p is not a square number. And I'm going to tell you why I'm doing this, because if you can't identify square numbers, the difference of square is going to give you problems. Perfect square is going to give you problems. Everybody with me? For this to be a square number, it had to be 100p square. Okay? So let's try one more. 16m square. Is this a square number? Yes, and the base number for this would be what? 4m, because 4m times 4m is 16 square. Last one, 9p to the second power. Is this a square number? No, this is the question I have for you. What is the base of this number? If 4m is the base of 16m square, what is the base of 9p square? Excellent. Excellent job, everybody. Excellent. 3p. Very good. All right. So the perfect square, now that we know this, it's going to be so easy. So let's go. This is the formula. Anytime you have a square number minus another square number, you factorize it like this. The base of the first number plus the base of the second number, second bracket, the base of the first number minus the base of the second number. That's it. This is the formula. You have to memorize this. You have to know this out your head. So let's do a quick example. Let's say I have q squared minus 4. Is this the difference of two square numbers? Yes, because my a, which is the base of q squared, would be q. Do we agree? My b is the base number for 4. What's the base number for 4? 2. So how do I factorize this? My a plus my b. What is my a and my b? A is q, so it's going to be q plus, what is my b? 2. And q minus 2. Let's do another one. So everybody understand how to use the formula? You find out who is your A, who is your B, and you just put A plus B, A minus B. In this example, my A was the base of q squared, which was q. My B was the base of 4, which was 2, and I just plug it into the formula. Let's try this one. 9a squared minus 16. Can anybody tell me what my A is? I should have used a different letter, but still. What is the base of 9a squared? Okay, so one person said 3, one person said 3a. Remember, you have to look at both parts, the number and the variable. So it's going to be 3a. What is my b? Who could tell me what a b is? Remember, b is the base of the 16, the second number. So excellent. My b is going to be 4. You see why you need to know your square number so you could do these things fast. So how do I factorize this? It's going to be a plus b, a minus b. So it's going to be 3a plus 4, 3a minus 4. Can we do one more? Let's do one more. Let's try 25p squared minus 1. First question, is this the difference of two squares? Yes or no? We almost done, guys. Yeah, of course. So if you look at it, don't forget that 1 is a square number. CXCers do this to people all the time. They just try to trap you. Don't get catch, fams. Don't get catch, fams. You should know, man, that 1 is a square number. Yeah, fam. So what would be my A? Talk to me, peoples. All right, so you're more confident, and I love that. Don't forget, it's 2 parts. Is it just 5? Is it just P? Or is it 5P? Period. 5P, because the base of 25p squared is 5P. Now, what is my B? What is the base of 1? If I had $5, I'd give everybody $5. Very good. Very, very good. Excellent. Very good. So I would like everybody to tell me how to factorize this. What? Give me the 2 brackets then. Tell me the first bracket. What's the first bracket? Excellent. That's 1 person. Very good. Bye. I don't even know how to download a Cash app. Did us use that in St. Kitts? I just feel too much scamming that's be going on, I don't trust them things, Our mobile bank, yeah, local vibes only. Okay, very good, guys. Okay, second bracket. What's the second bracket? Very good. That's it. You see how easy, I'm gonna be honest with you. Factorization easy once you remember the rules and know when to use each one. So right now we are 3 out of 5. How are we feeling about difference of square? We good to go? Are we good to go? Yeah. Are we ready to move on to the next one? Perfect square. Excellent. So make sure you rate yourself, yeah? Would you give yourself an 8 out of 10 or a 9 out of 10? Rate it so you know how much you need to go. All right, then. We got 2 more to go and then we're done with class. The next one is what we call the perfect square. Perfect square. No. This has a general formula as well. So you see how to identify the difference of two squares is easy. To determine the perfect square, this is how our perfect square look. But before I do that, y'all know this one? Y'all know the formula for this one already? If you know it, like as in you know how to do it already, good. Say yes. If you don't know or you're not sure, say no. So I could know how much people know it and don't know it. Okay, so far I've seen a lot of no's. Okay, because I'm gonna be honest with you, based on exam trends, this is the one students tend to struggle with the most. This is the one they don't pick up on. So this is the one that I'm gonna just spend maybe a little 5 minutes on to make sure you could identify it properly and you're confident with it. Because the AC rule is easy, which is the last one. All right, so let's go. This also has a general formula. So let's go back just to recap what we've done so far. The distribution, we know, what is the distribution? All the terms got something in common. And so you divide out the common term and you put what is left back in the brackets. That's the easy one. Grouping has 4 terms. And the reason we call it grouping is because you put the first 2 together, the second 2 together, and you factorize what they have in common, and then you break it down from there. Easy stuff. Then we did the difference of 2 squares, and this is the general formula. So this is something y'all need to have a picture of, I think, to be honest. Did y'all take a picture of this one? Take a picture of this one. Sorry about that. You definitely need this one. So take a picture. Let me just put a box so you can see what you're taking a picture of. You're taking a picture of this one for the difference of 2 squares. Okay, because you should take note, you should write this down in your books. And you see how we had a general formula. If the expression looks like this is how you factorize it. You just substitute it into it. That's all. Okay. And based on what I saw, y'all look super good with that one. So now we're going to go into the perfect square, which also has its own formula. Okay. So this is how the formula for the perfect square looks. The first number is a square number plus 2ab plus b squared. So this is the first trick about this. The first number and the last number are what? Square numbers. Everybody see that? I need everybody to talk to me. Communication is key. Because before we move forward, I need to make sure you understand that's the first key you're looking for. Because you remember, every one of the factorization got something you're looking for. The perfect square starts with a square number and ends with a square number. Okay? Then, just like what we did for the difference of square, what did we do for the difference of square? We found A and B. So when you find A and B, you find A, which is the base of A. You find B, which is the base of B. Then you have to find 2AB. What does 2AB mean? That means 2 times A times B. Now, this is how you check to see if it's the perfect square. If when you multiply these things and you get the middle number, you're good to go. If you multiply these 2 things by 2 and you get a different number than what here, it's not the perfect square. If you don't understand what I said, don't panic. We're going to do some example so that you can see what I'm talking about. Okay? Y'all ready? Give me 1 second. Something happened here. So I'm just trying to find my question on my board. I know we did a lot here, so I just want to send a massage. I send in all of your brains a hug because Like, we did a lot in 2 hours, and I'm very proud of you guys. So big up yourself one time. Look out for the mobile banking, $5. Factorization. All right, so let's take a look here. Sorry, I had something here that I was using and I lost the page. So just give me 1 second, okay, guys? Just give me 1 second. Okay, I'm ready. All right, so let's go example 1. Oh, so what I told you, what I forgot to put is how to factorize it when you realize it's a factorization, perfect square. Whenever you realize and you confirm it is perfect square, you just put a plus b bracket square. So you see how before the difference is square, what did we have to put? We had to put a plus b and a minus b. But for the perfect square, all you have to do is put a plus b squared. That's why they call it perfect, because it's the same exact thing. So let's look at question number 1, example number 1. I hope everybody here with me. We almost done. So this is the first question. P squared plus 8p plus 16. All right, let's go. Before we decide if it's the perfect square, we need to verify some things. The first thing we gotta verify is the first and last term square numbers. Yes or no? Talk to me, my good people. Let's go. We in this to win it. Is the first and last term square numbers? Okay, good. So what is step 2? Remember, step 2 is always identify who is your A and who is your B, right or wrong? So what would be my A? And I believe everybody should be able to do that. What would be my A? If p squared is the number and we want to find the base of p squared, what is p squared, the base of p squared? That would just be p. Do we agree? The base of p squared is p. Who could tell me what is b? What is b? Check it again. Remember the base of 16? What's the base of 16? 4. Good. Now, can I just assume it's the perfect square with only that? No, we got to make sure that the middle match. So now you have to find what? 2ab. What does 2ab means? 2 times a times b. So that's 2. What is a? P times b. What is b? 4. When I multiply this, what do I get? 2 times p is 2p, and 2p times 4 is 8p. So guess what? Does it match? Is it the same thing? Yes. So that means this is the perfect square. So that means you could say perfect square. How do we factorize the perfect square again? It's simply a plus b with a formula. A plus b with a square outside. So how do I factorize this then? What is my a? P plus 4 square. Yeah, I'm glad you asked that. That is for the AC rule using a quadratic. That's completely different. So I'm glad you mentioned that. Because this is the perfect square, it uses different letters, okay? When we do the AC rule, they're going to deal with the quadratic equation, which is going to use the C. And I'm going to show you just now, okay? So excellent question. Somebody was asking if C isn't C. And we're going to talk about that in a few minutes. But I want to make sure everybody understand how we did this. And you realize it's kind of simple if you look at it. Let's try another one. Let's try another one. Oh yeah, I forget to tell y'all, this got 2 formulas, when A is positive and when B is positive. So here, you realize everything is positive, so it's A plus B. Sometimes it got a second option when it looks like this. A squared minus 2ab plus b squared. And instead of saying A plus B, it's just going to be A minus B, close bracket square. So it's two versions of the same formula. Everybody with me? So one is positives, which is our positives, and one has a negative here. So instead of A plus B, it's going to be A minus B. And I'm going to give you one example like it right now. So check this example out. M square minus 10M plus 25. So let me go through. Does this look like the perfect square? What would be my A? Anybody? What would be my A in this example? Excellent. Somebody said M. Is that true? Very good. M is the base of M square. What would be my B? What is the base of my 25? 5. Is that true? The base of 25 is 5. Good. So what do I need to check for now? The middle part, 2AB, right? Which is 2 times M times 5. And if you multiply that, you're going to get 10. M. So that tells us it is the perfect square. But instead of saying A plus B to the second power, it's going to be what? Because here is a minus, it's going to be A minus B. So who could tell me what's going to be in the brackets? It's going to be M minus 5, close bracket square. Everybody see that? Guess what? That's it for the perfect square, you know. It don't get any harder than this. If you could do this, that's it. It is not. So, okay. I love how you said that. Let's look at another example. Let's see if this works. Q square plus 16Q plus 4. All right. I have a question for everybody. Is this the perfect square? Do you think this is the perfect square? Let's check it out. What is my A? A is what? Q. B is what? 2. So let's find 2AB. 2 times Q times 2. How much that gives me? 2 times Q is 2Q times 2 is 4Q. Is this the perfect square? I'm not moving on until I get answers. So we could stop right here or we could continue if everybody let me know what they think. Everybody realize whites now? Everybody see whites now? Do they match? Up here, you got 16Q. But when you check it out, this gave us 4Q. So this is not the perfect square, so we can't factorize it using that. Which would lead us to our last factorization, AC rule, and that's it for tonight. So this is the last thing we're gonna do, the AC rule, and we're done. I can't believe we actually make it to thing. How y'all feel about the perfect square though? Everybody okay with the perfect square? Do you realize the perfect square and the difference of two square are almost kind of similar? The only difference is the second part, how you factorize it. So put your rating if you know you need more practice, because I'm assuming most of you would have learned this for the first time now. So obviously you're going to need a lot more practice. So please take a picture of the screen. And I recommend that you do some practice. I'm going to send you out some questions to practice. And this is the third example. And now we're going on to the last one. So my question is, do y'all want to end here or you just want to finish the last one and done at the last one? So do the last one? Okay. Okay. So we're going to do the last one. And that would bring us to where we need to be. All right. Let us go, my awesome people. Let us get into it. So this is the last one. No, like somebody said, let me just start a new page so we got more space. Take a deep breath. This is just, this one includes the most work. No. How much of you, before I begin, are aware of how to factorize using the AC rule? If you don't remember, say no. If you don't know at all, say no. If you I'm watching. Okay, so a lot of people not too confident with the AC rule. Okay, so listen to me. The AC rule is used for quadratic equations. What do I mean by quadratic equation? Anytime you have something that look like this. So let's first say quadratic equations. And if you don't know what a quadratic equation is, it's anything that has an x with a power of 2. So for example, it does look like this. Something x squared plus something x plus a number c. So what you're going to realize is that a always is the coefficient of the x squared term. So it doesn't matter where the x squared is. A could only be the number in front of the x squared. B is the coefficient or the number in front of what? What is B in front of? The coefficient of the x, right? And C is what we call a constant, which is known as a number by itself, okay? So a number. So what is 2 plus 3 plus 4? That's the number. Everybody understand what A, B, and C is? Because if you don't understand what A, B, and C is, it's a lot different than what we was doing before. So everybody got it? Let's finish strong. Hello? Can you hear me? Are you there? Come on, guys. We almost there. Okay. So let's go. I'm going to write out some examples of equations that look like that. So let's look at the first one. A first example would be x squared plus 7x plus 10. So my question to you is, in this example, what is A? Let me see who's thinking. What is A in this example? Because this is what going to determine things like who gonna pass, who gonna remember. You have to remember these things. Some people saying 1. Is it true? Yes, because even though there's no number in front of x squared, what did I say before? All variables have a coefficient, and if there's none, the coefficient is always what? 1. Everybody see that? Don't forget. And it is not 1 x or 1, a number is just 1. It's just 1 alone. X squared is the variable, 1 is the coefficient. What is B in this example? So A is 1. What is B? Excellent. And what is C? C is 10. No, if this was minus 10, do you know that C would have been negative 10? Because the expression only calls for positive values. So if this is turned into a negative, that means C is negative. All right, so let's start off with the AC rule. There's a reason why we call it the AC rule. Anybody know what AC mean? AC means A times C, right or wrong? So that's the first thing you have to find. Step 1, find AC. So in this case, what is my A? My A is 1. So I'm going to say 1 times, what is my C? 10. So that means AC is 10. Everybody understand the first part? Because that's the easy part. You multiply your A and your C. That's why we call it the AC rule. 2, find the factors. Do I need to write out these notes? Or are you just going to follow? Just follow for now. 2, find the factors of 10 that add up to 7. So let's break it down. What are the factors of 10? 1 and 10. But when I add 1 and 10, it gives me 11. That's not 7. Let's try another set of factors. 2 and 5. How are we looking? Is this what we want? If I add 2 and 5, does it give me 7? Yes. So we're going to choose 2 and 5. So you know why we just use these numbers? We want to rewrite this equation to have 4 terms instead of 3. And when I do the 4 terms, I want to see if anybody realize why. So what we do is we break up 7x, and instead of 7x, we're going to break it up into 2. What do you think we're breaking it up into? 2x plus 5x. So check it out. We're going to end up with x squared, same thing. Everybody see that? But instead of saying plus 7x, we broke it up into 2 using the factors. So you're going to be 2x plus 5x, and then we put back the plus 10. What's the only difference that I did? We moved from 3 terms into 4. Why you think we could do this? We can't factorize this. We didn't learn how to factorize 4 terms. What type of factorization is that? Excellent. You factorize by grouping. And guess what? We don't learn that second part. So if you ain't realize what's going on here, the AC rule literally is just this part, and everything else from here is by grouping. So let me go. We group the first 2. We group the second 2. Everybody with me so far? What can I pull out from x squared and 2x? What both of them have in common? In x. When I pull out x, what's left back? If I got 2 x's here, because x times x, you pull out x, 1 x left back. If I pull out x from 2x, what's going to left back? The 2. How are we feeling? We okay? In the second bracket, what do both of them have in common? Both of them have 5 in common. So you pull out 5. When you pull out 5, we know what we mean by pull out, right? We divide by 5. Right? I'm just doing this just in case people forgot. So what we're going to have left back? We're going to have left back x plus 2. This ain't look familiar. This ain't exactly what we did before. How do we know we're going right? How do we know we're going right? The 2 brackets matching, right or wrong? So what is our actual answer? X plus 2, which is the common brackets, and everything else outside, you put in a bracket together, which would be what? X plus 5. Now, let's be honest. Is this really hard? If you think about it, because from here, we know what to do. The only part students forget is the AC part. And like I said, follow the instructions. Find AC, find the factors that add up to the middle term, and you split the middle term to get 4 terms instead of 3. Okay, no worries. Let's do another one together. Let's try another one. Let's try this one. I'm going to use the same numbers, x squared plus 7x plus 12. Let's start off with A. What is my A, everybody? Let's take it step by step. What is A? What is the coefficient in front of the x squared? Remember, that's 1. Remember, it's the coefficient you want, right? Everybody with me? So A is 1. What is B? Let's go, guys. Let's go. Especially if you know you're not confident. B is 2. Sorry. What is C? Sorry, not 2. C. B is 7. Again, a little tired as well. B is 7. And C is 12. So everybody understand that part? Hold on for a minute. All right. Everybody with me? So we know the A is in front of the X square. The B is in front of the X. And the C is the number in the back. That's where we get them from, right? In the expression itself. So once you find out who's A, who is B, and who is C, we need to find AC next. Anybody could tell me what AC is? What number it's gonna be? If I multiply A and C, what number will I get? Because 1 times 12 is 12. So my AC is going to be 12. All right. After this, we're going to pause and we're going to end. Just because I don't want to overwhelm anybody. And we're going to start off with this next class. Okay. So let's just end off with this one. And then I have one question for you guys and then that's it. So let's go. What should I do next, guys? Aim find factors of 12 that add up to 7, right? So let's find the factors of 12. 1 and 12, because 1 times 12 is 12. Let's go. The next one is what? 2 and 6, but 2 plus 6 is 8. I want 7. What's the next set of factors? 3 and 4. Does 3 plus 4 give me 7? Everybody with me? Did I find my factors? So this is the one I want. And this is the part we need to remember. Why are we using this? Because we want, instead of having 3 terms, how much we want? We want 4. And we know why we want 4, because we want to use what? The factorization by grouping. Remember, it's always good to know why, eh? Why? So what number we changing? We changing 7. Yes, Amije. We changing 7 and breaking it up into 2. And instead of having 7x, what are we going to end up with? 3x and 4x. So let's write that. So we're going to have x squared plus 3x plus 4x plus 12. All we did is break up this 7x into these 2 here using the factors. Everybody realize that if I add these 2, make I get 7x, it's the same thing. All right. From here, we know what to do. We have 4 terms, so we group, we factorize by grouping. We group. What do these 2 have in common? They have x in common. When I pull up my x, I have x plus 3. You should know why, because we practice this. In the second brackets, what do they have in common? They have 4 in common. So you pull out positive 4. What's left back? X plus 3. How do you know you're looking good? Your brackets match. So you're going to end up with x plus 3. And what's left back? Outside, you put in a bracket by itself, x plus 4. And that's it. Everybody see that? So for the purpose of notes, take a picture of this screen. Again, please note, we only could do so much in this 2-hour session. So your job is to look at what you realize you're not good at and where you need more practice. And you could always message me for extra questions, okay? I mean, I'll answer immediately, so give me some patience, but that's it. All right, so to wrap up tonight, I would like some feedback on, do you think tonight was useful and helpful to you? That's the first question. Did you think that you were able to follow along, even with things that you didn't necessarily understand? Do you guys want to continue next week, Sunday? I hope you guys enjoyed the session. I hope you were able, nobody fall asleep too much. And if you fall asleep, you wake up. I believe that with hard work, anything is possible. So My aim is to support you to pass your exams, okay? But you cannot rely on my class only. And if you're going to other classes, please put in the work. Please practice. Be smart and be gangster. Be brave. If you do something, and this is what I would like to say, I'm gonna send you guys a YouTube video so you could just skip through to the questions, and this is what I would recommend you do for homework. All of the questions we did tonight, copy them out in your book and see if you could do them by yourself. And if you can't, you go back, you look at it, and then you try it again. Math is about practice and doing. You can't look at the screen and remember what I did tonight, because it's not gonna stick. You're gonna understand today, and tomorrow all of it gonna evaporate. Unfortunately, that's how maths is, eh? You got understand in class and you're going by yourself, in shambles again. You have to practice. You have to practice, okay? So next week, same time, same place. Okay? Shoot me some WhatsApp messages, because I would really like some feedback, you know, to just encourage more persons to come and learn. So if you don't mind, just send me a WhatsApp message, just giving me your review. And if you have any criticism as well. So if, for example, you think that maybe I talk too fast, or if you have some recommendations, I like to learn as well from my students. So share with me anything that you think that could make this session more useful, okay? So thank you so much for being here with me tonight. I hope to speak with you and work with you further in the future. So big up yourself. Bye.